This is a demo of Grid, a smart distributed electrical system I came up with. It's just a prototype for now, so it's pretty bare bones and simple, but the idea is you would run this on a particular entity connected to the grid. So that could be a house, a power plant, the house is or a business. You could run it on a house that has a solar panel or that produces energy, or on a house that just consumes energy, I think like most residences. So the way this works is, let's say you started up on your house. Right now we are printing out every second, we're printing out the current state of the node. And you can see here it's showing its energy values. So all energy values default to 0, 0. This is showing a production of 0 and a consumption of 0. Again, all entities can both produce and or consume energy. And so we're going to start up a couple different nodes in, let's say, a neighborhood. So right now all these nodes are running. They all represent different houses, businesses, whatever. And they currently are not associated with each other at the moment. All nodes, the way you communicate with each other or communicate with the outside world in general is by sending them messages. So for example, let's start by sending a update energy message. Let's say that we turn on all the lights in the house and we spike consumption 10 units. So we turned on all the lights on, and you can see it received this message, updated its energy values, and it also updated the grid net. Because this node is technically a grid of 1, it's not connected to anyone, it has a grid net of -10, because 10 production, or 0 production minus 10 consumption equals -10. So let's also do the same thing for B. Let's say B has a solar panel, it's producing 20 units of energy, and they're pretty conservative with their energy consumption, so they're only consuming 5. When I send them the message, notice I'm sending it to 8082, which is B's address. A is 8081. Notice that it updates its energy to producing 20 and consuming 5. The grid net result of that would be 15, because 20 minus 5 is 15. So now let's make it interesting. Let's actually associate these two with each other. So I'm now sending a message to A to add B as a sibling. Now notice the going back and forth here. And I'll just pause it for a second here. The reason they have to go back and forth is because all sibling adds need to establish a bi-directional relationship. So when I send a message to them to add the sibling here, A then sends an ask request to add the sibling to B. B then responds. You'll notice B is receiving the ask request here, updating their siblings, and then responding to A. A receives the response and then updates their siblings. Notice also their grid net is now updated. They both are in sync. They both have a grid net of 5 because -10 plus 15 is 5. So that's the main functionality of the grid, is that both of them can have their own individual consumption and production values, but they stay in sync if they're part of a grid. So let's now add the rest of the siblings. So what we're going to do now is add, so A and B are siblings. You'll notice, by the way, their siblings attributes are now updated. They're siblings with each other. And then B and D will be siblings, D and C will be siblings, and C and A will be siblings. So we're going to send those messages now. So sending to B, sending to D, and sending to C. Now, this may take a little bit of time because I am printing the responses. I'm processing the responses with a 1 second interval just so you can see the messaging going back and forth. Normally, obviously, this would happen in milliseconds, but just so you can visualize all the messaging going on back and forth. What happens now is for every add sibling message that gets received, that node is now connected to whatever grid it's adding the sibling to. So it needs to get re-synced up in terms of the grid net because now there are a bunch of new values in the system as a whole. So what it does is it actually sends a sync grid message. So it adds a sibling, they do the back and forth, and then it sends a sync grid message. Sync grid messages get forwarded throughout the entire system. And let's see if we can find one in here. A lot of update net. Yeah, sync grid message. So notice that this node is receiving the sync grid message. That means another node had sent it. Once you send a sync grid message to your siblings, the message continues to get forward until it hit the leaves of the graph, and then it stops. If you receive a sync grid message, that triggers an update grid message. Every single node, because it's a distributed system, is responsible for its own grid values. So if you receive a sync grid message, that means that you, as a particular node, need to then update your grid and get resynced up with the entire grid. So you'll notice that after a little bit of back and forth, they all start showing this updating grid net to 5. That's because the two new nodes down here both have production and consumption values of 0, so it doesn't actually affect the original grid net that we had established before. But they don't know that, so they need to go through the whole process of updating the net. The updating net is similar to the sync grid message in the sense that it goes all the way to the end of the graph until it hits the leave nodes. Once it realizes that there's no more nodes to hit, it then retraces its step, collecting all the personal net values of each node that it once passed through. So this is to ensure that we're not missing any net values. We're making sure that we're actually summing all the net values up, and then once it comes back to the originator, it then sets their grid net. And all the messages have now settled down, so we just go back to printing the current state because there's no messages being passed back and forth. Just as an example of how that gets propagated, let's send an update energy of 20 production and 30 consumption to number 4, which would be D. So you'll notice it's going to happen, it's going to appear here first and then propagate through the entire system because we now have new values that are affecting the total grid net of the entire system. And as you can see, it receives the tell, then sends the update net ask and the sync grid net ask. The reason it happens in that order is because it knows the receiver of the update energy message knows it needs to update its own net. So it starts to do that first. But then it also knows that it needs to tell everybody else they also need to update their net. So that's when you see them send out the sync grid. That's also when you see all of them start to actually update their own nets as well. And it looks like that was resolved, and we now have a -5 grid net value because, let's see here. Yep, because we added -10 net to the entire grid, and I think previously it was 5, so the new grid net is -5. And that is essentially how the grid works. Thanks for watching.